This question is asked in gate 22 of ECE. This question is from signal subjects and from Fourier transform topic, continuous time Fourier transform. Okay. The question is the Fourier transform x of j omega of the signal x of t equals to t by 1 plus t square whole square is dash. Okay. So these are the options we have. So if you see the function x of t, okay, so if you have good practice, you must be getting the idea these questions can be solved using the property of duality. Because we have seen some function in x of omega domain which looks something like this, like 1 plus omega square model. And in place of omega, you have t. So such kind of questions are generally framed based on the duality property. So let's see how we proceed, okay. So what I can do is, so let me take some reference. The reference is this. So, you know the standard pair e raised to power minus a mod t, if this is what a continuous time signal x of t, its Fourier transform is given by 2a by a square plus omega square. I believe all of you know this. This is a very standard results. But if I observe, okay, so if I, okay, or to be very specific, let us take a value 1. If I take a value 1, e raised to power minus mod t, this Fourier transform is 2 by 1 plus omega square. Now, if you compare this expression with this one, so you can see this 1 plus omega square here, you have 1 plus t square, but again you have a square function here. So for that, what I'm doing is, so let me multiply t. So if I multiply t, what is the benefit of multiplying t? So what this property says, if I'm multiplying t, then you have to differentiate the other side. This is the frequency differentiation property. So t into e raised to power minus of mod t, its Fourier transform is j into d by d omega of 2 by 1 plus omega square. This is what is the property. Now, what is the benefit I'll be getting? So if I'm differentiating this function, so you will again get a square function. So I mean, because my target is to get a square term here. If I differentiate this function, don't you think you'll be getting a square in this factor? Yes. That's why I'm using this property. So if you simplify this t into e raised to power minus t, so how much will you get? So t into e raised to power minus t, okay, its corresponding CTFT. So if you simplify this, so this happens to be minus of j4 omega divided by 1 plus omega square and whole square. Isn't it? So very simple, straightforward differentiation. So this is what this thing is. Now here let us use the corresponding property. So what is the duality property says is, duality property is something like this. If x of t having Fourier transform x of omega, then x of t having Fourier transform 2 pi into x of minus omega. That means if you have a standard Fourier transform pair, in this omega function, if you are replacing omega with t, its corresponding Fourier transform is 2 pi into x of minus omega. So this x of minus omega is nothing but you are replacing this t with minus omega. So this is the standard duality property. If I use this, so what do you get? So I can say, so if I am replacing in this function omega with t, what do I get? So I get minus of j4t divided by 1 plus t square whole square. Just I have replaced this all omega by t. Minus j4t divided by 1 plus t square whole square. Its corresponding what? CTFT will be by this property 2 pi into x of minus omega. So x of minus omega means in this function x of t, wherever this t is there, replacing it by minus of omega, right? So similarly, I have replaced all the omega by t. So in this function, wherever t is there, I will be replacing with minus omega. So this is minus omega for this t. Then it is e raised to power minus of, in place of t, again it is minus of omega. So this is what is the case is. So now if you see, so but we need with respect to this t. So we have t here. So this minus j4 I should take it to other side. So I can say t into 1 plus t square and whole square. So this time Fourier transform, if you bring this minus j to this side, this is 2 pi j divided by 4 and this is minus of omega into e raised to power how much? Minus of mod of omega, right? Because of mod function, so this minus will be plus. So now if you see this, so I can say t divided by 1 plus t square whole square, its Fourier transform is, you can write this as j, okay, so if you observe in the questions, I mean in the options, Wherever j factors are given in the denominator functions, right? So b and d, anyway, this will be wrong because there is no j factors. So we have to arrange this function by putting the j in the denominators. So what I'm doing is, so if I take it to denominators, so this will be, this is one minus is there, right? So this is pi by j2, this is omega into e raised to power minus of mod omega. So because you can see this is a minus sign is there, so minus j is equivalent to 1 by j. So this j I am putting here, and 2 and 4 this will be cancelled, so it will be pi by 2. So overall it is pi by j2, and then it is omega into e raised to power minus of mod omega. If you observe, so this is given in which option? Option A, right? If you see, this is given option A, pi by 2j omega into e raised to power minus of omega. Pi by 2j omega into e raised to power minus of mod omega. Okay, so what we have done in these questions? So I have taken a standard pair, which is this one. Then I have observed in the original questions we have a square term. So for that, I thought of to get the square term, I'll be differentiating it. And for differentiation in frequency, you need multiplication of t. So this function having Fourier transform this much, then using the duality property, I have replaced this all omega with t. Correspondingly, these all t will be replaced by minus of omega with a multiplying factor of 2 pi. Then by simplifying or rearranging, so this function Fourier transform is this one, which is given in option A. So this is also not a tough questions, okay? You need hardly 1 minute to answer this. This question is asked in gate 22 of EC. This is from signal subjects and from the convolution related topic. The question is, let x1 t is e raised to power minus t ut, x2 t is ut minus u of t minus 2, where u denotes the step function. If yt denotes the convolution of x1t and x2t, then limit t tends to infinite y of t is dash. So basically, what is being given is, we have two function x1t and x2t, and the third function yt is given as x1t convolved with x2t. So such kind of questions can be solved using Laplace, using graphical methods, or by using some standard results. Basically, just manipulating the equations. So I would like to solve these questions using this standard results only, which will be very straightforward. So I can say your yt is equals to x1t. If I substitute, it is e raised to power minus t ut. Convolve with x2t. If I substitute, this is u of t minus u of t minus 2. So if I'm simplifying this, this is e raised to power minus t ut convolve with ut. Okay, then you have minus sign, that's why it is minus. Then it is e raised to power minus t ut convolve with u of t minus 2. So the standard results, I hope all of you know, e raised to power minus at ut convolve with ut is given by 1 by a 1 minus e raised to power minus at ut. Okay, na? This is what the standard results. If I substitute a equals to 1, so what do you get? If I substitute a equals to 1, this is e raised to power minus t ut convolve with ut is equals to 1 by a. A is 1 means it is 1 minus e raised to power minus t multiplied by ut. So if I write these results, so this become 1 minus e raised to power minus t ut, and what do you get here? So here it is u of t minus 2. So using shifting property, this is 1 minus e raised to power minus of t minus 2 into u of t minus 2. Okay, na? So how I am doing this? Using the shifting property. So what is the shifting property? So let's say x of t convolve with h of t, this is equals to g of t, for example. So if I am shifting one of the signal, that is, let's say if I am replacing this h of t by h of t minus t naught, then the overall answer is g of t minus t naught. That's what the property says. So in other words, I know these results. Okay. So, like in this case, what is, if I say this is your x of t, this is your h of t. So what is being happening in this case? So this is your x of t and this is your h of t minus t naught. So the final answer in this case will be with respect to the result of this. So in this results, you have the, you have to replace the t with t minus 2. Okay. So that's what I did here. So this is what is the expression of your y of t. But what we are supposed to find? We are supposed to find y of infinite. So if I substitute t equals to infinite, this is 1 minus e raised to power minus infinite and into u of infinite minus 1 minus, again it is e raised to power minus infinite, and this is u of infinite. Okay. So if you solve this now, so 1 e raised to power minus infinity is 0. So this is 1 minus 0 into u of infinity is 1, because u function look like this. Its value is 1 at even t equals to infinity, right? So u of infinity is 1. Minus, it is 1 minus again 0. So this is 1 minus 0 is 1 into 1, 1 minus 1. So the answer is coming to be 0, right? So this answer is 0. So you can even attempt these questions using graphical approach or even using the Laplace. Okay, all way you can solve. The answer will be definitely 0. This question is asked in gate 22 of EC. This is from signal subjects and from the system related concept. The question is, the output for 4 system S1, S2, S3, S4 corresponds to the input signal sin t for all time t are shown in the figure. Based on the given information, which of the 4 system is definitely not LTI? Okay, so you have to identify which of the system is non-LTI system. So what is being given is, let us assume the input to all the 4 system is x of t and the output is y of t. So let us try to express the yt in terms of x of t by observing the relation. If you see in the first system, okay, S1, so what is the change? So if you compare the input and output, so only thing is in the output, we are replacing the t with minus t in the inputs. So I can say yt is equals to x of minus t. That means in x of t, if I am replacing t by minus t, I am getting output yt, which is sine of minus t. In the same logic, in the system 2, in the input, if you are replacing t by t plus 1, so you replace the t with t plus 1, so you get sin t plus 1. So yt is equals to x of t plus 1. In the third case, again the same logic, you are replacing t with 2t. Okay, t is replaced by 2t. So what is the equation then? Yt equals to x of 2t. So in the fourth case, sin t is the input, output is sin square t. So I can tell your yt is equals to x square t. Right? So these are the 4 relations. And these are very basic things that while learning the linear, non-linear, time-variant, invariant system, we used to study these all things, right? So we can easily tell. So if I compare these all equations, in the first 3 cases, you can see we are not doing anything on the amplitude. So only manipulation is happening on the time. Here this is time, time, time. Nothing is changed in the amplitudes. So if you are not touching amplitudes, so definitely all these 3 systems are linear. Definitely they are linear. And the last system is non-linear. Why the last system is non-linear? Because here we are, manipulating the amplitude. Like you do x square t, you do x cube t, you do square root of xt. So if you are manipulating the the amplitude, so it will be definitely leading to the non-linear case. Okay. So linearity we have commented. Let us now comment regarding the time variant invariant. In the first case, in the last case, that means in the S4. So here it is definitely time invariant. Why? Because if I am delaying the inputs, okay, if I am delaying the inputs, because the system behavior is squaring it. So if I am delaying the input means my input is x of t minus t naught. If I give it to square it, it is x square of t minus t naught. But whether is it equals to y of t minus t naught? So y1t is this one. Whether is it equals to y of t minus t naught? If I am replacing t by t minus t naught, it is x square of t minus t naught. So yes, in this case y and t and y of t minus t naught are matching. So this is time invariance. Now what in this S3 case, that means in this case. So again, you check it by giving the input x of t minus t naught. So if you give the input x of t minus t naught, if I let it to y1t, so this will be x of 2t minus t naught. So what we are doing, we are just changing the t by 2t. So if I am giving the input x of t minus t naught, if I am replacing the t by 2t, this is what I am getting. But whether is it equivalent to y of t minus t naught, if I am replacing the t by t minus t naught, it is x of 2 whole multiplied by t minus t naught. So here you get 2 t naught factor, but here it is t naught. So this is definitely time variant. So this is time variant system. So in the third, so in the next case, that is in the system S2. Okay, in the system S2, so what's going to happen here? So here in the system S2, so what is your y1t? Y1t means you are giving the input x of t minus t naught. So what the system will do, it will replace the t by t plus 1. So t plus 1 minus t naught. And what is y of t minus t naught? Y of t minus t naught means wherever the input t is there in the x of t replaced by t minus t naught. So if I'm replacing it, it is x of t minus t naught plus 1. Whether both of these are same? Yes, both of these are same. But what it is then? Then this is time invariant system. In the fourth case, okay, in the same logic you try. So what is your y1t in this case? Y1t is nothing but the input to delayed input. So what you get? So the t will be replaced by minus t. So it is x of minus t naught. But what is y of t minus t naught? So y of t minus t naught is x of minus t naught. So it is x of minus t plus t naught you will get. So this is basically your coming time variant because both of these are not same. So this logic, if I summarize, so what are the conclusion we have derived is, so the conclusions are, so in the first case the system is linear and time variant. In the second case linear and time invariant. Third case linear and time variant. And in the fourth case non-linear and time invariant. Right? So this is what the conclusion we have. So, so first case linear time variant means non-LTI, because to say it is LTI, it should satisfy both linearity and time invariant. So it is non-LTI. Second case linear and time invariant. So this is your LTI system. Third case linear and time variant. So it is again your non-LTI. And in the fourth case it is non-linear and time. So this is again your non-LTI. So what are the questions? Based on the given formula, which of the four systems is are definitely not LTA system? Not LTA system. Which is not LTA system? Okay. So which is not LTA system then? So what is the answer then? Not LTA system means what? Which is not satisfying? Non-LTA system. So definitely it is system S1 and system S4. So that is basically this is a MSQ questions. S1 and S4, these are non-LTA system. Okay. One second. Which are definitely not LTA system, right? So even C as well, right? Even this one also. This is also. So except this middle system, remaining all are non-LTA. So S3 will also come into pictures. S1, S3, and S4. So these three are non-LTA system. Okay, so because I have explained, I have taken around 10 minutes of time. But if you solve in a proper flow, by observing the equation itself, directly you can tell whether these are LTA or non-LTA. Okay, so it's MSQ. That's why it is the term is or are used. Okay, so three of them are non-LTA. Only the S2 system is LTA. So answer is A, C, and D. This question is asked in Gate 22 of Electronics. This is from Signal Subjects and from the DFT topic. The question is, for a vector x bar is equals to x0, x1 up to x7, the 8-point DFT is denoted by capital X complement, which is DFT of small x complement is capital X0, capital X1 up to capital X7, where x of k is this equation, which is the standard DFT equation, where j is square root of -1. Then it is saying if x complement is 1, 000, 2, 000s, and y complement is DFT of small x complement, then the value of y of 0 is dash, rounded up to 1 decimal places. Every year there is a question from DFT, and this question is again looking a bit lengthy and tough the way it looks like, but most of the cases DFT questions, they look horrible, but most of the cases the solution is straightforward. So in this case, there are mainly two approaches. Using something called duality property, you can solve it. Otherwise, if you evaluate the DFT also, it won't take much time if you know the proper logic. Okay, so let me first write the corresponding data which are relevant for us. So first thing is small x complement is given as 1 000s, 2 000s. Okay, this is what is given. Okay, so and what we need to find? We need to find y of 0. Now, what is this y of 0? So we need to find this y of 0, right? And what is this y then? This is what is y. So y complements is nothing but DFT of x complements. So if I am letting DFT of x complement is xk, so basically we need to find DFT of this one. I mean DFT of small x complement is capital X of k. So your y complement is DFT of x of k. And in this function, we have to find the zeroth sample because y of 0 is what is required. So my task is, or my approach will be, first to get the value of this x of k. That is, I have to evaluate this DFT of x complements. Okay. Now, let me name g of n is 1, 2. This is what your g of n is. So do you mind if I say x complement is nothing but equals to g of n by 4? Because, like when you do interpolations, if you have, let's say, a sequence x of n, now if I'm asking you to find what is x of n by k, then after every sample you have to put k minus 1 number of 0. For example, if I'm saying x of n is a, b, c, if I'm saying what is x of n by 3, then after every sample you have to put 2 to 0 because 3 minus 1 is 2. So that's why 2 zeros. b 0 0, again c 0 0. In the same logic, okay, if g of n is 1 by 1, 2, then this x is nothing but equals to what? G n by 4. Because if it is n by 4, after each sample of gn, you have to put 4 minus 1, 3 number of 0. That's why 1 0 0 and 2 0 0. Okay, so why I am saying like this is, you see how I am proceeding this one. So, the point is, there is a property, okay? The property is something like this. If you know the DFT of g of n is, let's say, g of k, then if somebody asks you, okay, what is the DFT of g of n by m? What is the property of g of n by capital M, let's say? So this is given by gk like this. How many times? M times. Okay, so if it is g of n by 8, you have to write gk 8 times. But in my case, I need to deal with g of n by 4. So if I get the DFT of gn is gk, okay, then the DFT of g of n by 4 is gk 4 times. So I am writing gk 4 times by this property. So based on these questions has been asked in the past also. So this is a well-known property. gk 4 times. So I am writing 4 times because your m value is 4. So gk I have written 4 times. So let's get that first, because my ultimate goal is to get DFT of x of k. So first I am evaluating x of k. So what is x of k? X of k is nothing but DFT of x complements. So x complement is given. So I have assumed g of n is one sequence 1, 2. So x of n related to g of n by 4. Okay, this way. So what is g of k? So how to evaluate the 2-point DFT? Which is very simple. So g of n is 1, 2. So g of k will be given by a 2 cross 2 matrix multiplications 1, 1, 1 minus 1 multiplied by 1 and 2. So this is basically 1 into 1, 1 plus 2 is 3. Next, 1 into 1 is 1, 1 minus 2 is minus 1. So this is basically 3 and minus 1. So that means, as far as this question is concerned, if g of n is 1, 2, its corresponding DFT, g of k is coming how much? How much you got? 3 and minus 1. 3 and minus 1. So now you see. So what we can see now? So g of n by 4. So which is nothing but your x. Okay. So what is your xk? Xk is nothing but equals to DFT of what? X complement. Okay. So which is an x complement is g of n by 4. So which is DFT of what? G of n by 4. And this is what we said. DFT of n by 4 is gk 4 times. So gk value I know, which is 3, minus 1. So I can say x of k is gk 4 times, means I will be writing this gk 4 times. That is 3 minus 1, 1 time, again 3 minus 1, again 3 minus 1, and again 3 minus 1. So, this is what is your gk. I have written here 4 times. Okay, but is this what is everything? It's not, because the end question is not to evaluate x of k. The end question is to evaluate DFT of this one. So the first part I obtained, that is x of k I obtained. Now I have to take the DFT of this x of k. That means I have to again take the DFT of this sequence. Okay, so let's say that is your capital Y of k. What is it? This is nothing but dft of x of k. That is dft of 3 minus 1, 3 minus 1, 3 minus 1, 3 minus 1. Okay, so how do you get this one again? So there is one more property. Suppose f of n having dft f of k. If f of n having property d of f of k, then let's say this f of n is repeated n times. F of n, f of n, f of n, like this. If it is repeated m times, okay, then its corresponding dft is given by m into f of k by m. So I am doing like this. Why you need this property? Because I have to find the DFT of a sequence which is repeated combination of 3 minus 1, 3 minus 3 minus 3 minus 1. But in this case I have 4 times. So if I select the value of m to be 4, so okay, let me if I take it 4 times, so fn 4 times, then its corresponding DFT will be what? 4 into f of k by 4. So if I compare this way, what is your f of n? F of n is this one sequence, that is 3 minus 1. And what is f of k? F of k is nothing but DFT of this. So to get DFT of f of n, f of k, again we will be going by that 2 cross 2 matrix multiplications. This is multiplied by 3n minus 1. If you multiply this, what do you get? You get 3 plus minus 1 is basically 2, and 3 plus 1 you get basically this is 4. So if fn is 3 comma minus 1, then its corresponding DFT, which is f of k, so this is basically 2 comma 4. Okay, so I need this one, right? I need this one. So basically your yk, which is DFT of this sequence. So this is given by fk. Okay, what do you get? 4 multiplied by f of k by 4. So 4 multiplied by f of k by 4. So this is 4 multiplied by f of k by 4. So this is what your f of k. If I ask you to interpolate it, so because this factor is 4, after every sample you have to put what? 4 minus 1, 3 number of 0. So 2 triple zeros, 4 triple zeros. Okay. So this is what your y of k. So if you multiply this 4, this is 8, then triple zeros, then 4 into 4 is 16. Again it is triple zeros. This is what your y of k is. And here we are supposed to get the 0th sample values, which is basically 8. So the answer of this question is basically 8. Okay, so because I'm explaining you the properties and all in between, so I have taken around 10 minutes of time. But if you solve this question proper flow, it will take hardly 4 to 5 minutes, not much. So to summarize what I did, first thing is the question which is asked. So you have to find DFT of one sequence. So first my intention is to get the DFT of this sequence. Okay. So this sequence, I have derived a small sequence g of n which is 1, 2, and I have correlated the x of n with g of n using this x complement equal to g of n by 4. Okay. Then I have to get the DFT of g of n. So using this property, okay, I obtain the DFT of this x of n which is x of k. And we got that answer is basically 3 minus 1, 3 minus 1, 4 times. So I got this factor then, I got x of k. Then again I have to evaluate the DFT of this sequence. So again I have this beautiful property, if f of n is repeated 4 times, its DFT is 4fk by 4. And here f of n by comparison is 3 minus 1. I have evaluated its DFT which is coming 2 by 2 comma 4. And if I am interpolating it by 4, I will be getting 3 zeros. And I am getting this one. So the 0th sample value is 8 which is asked. So 8 is the right answer for this question. There is something called duality property. So there also we can solve. Okay. So you may attempt that way. But this is by knowing these two property also, it will not take much more than 4-5 minutes if you solve in a flow. So the answer is 8 for this.